Hello everyone, welcome to my channel. In this video, we are going to see some interview questions in data structures that are frequently asked by many companies and their answers also. What is a data structure? A data structure is a way of organizing and storing data in a computer's memory to enable efficient data retrieval and manipulation. Let me elaborate more on that. A data structure is a fundamental concept in computer science that refers to the organization and storage of data in a way that allows for efficient access, retrieval, and manipulation of that data. The need for data structure arises from the fact that different types of data requires different methods of organization to optimize their use. For example, some data may be best organized in a sequential manner, while others may need to be arranged hierarchically or as interconnected elements. Selecting the appropriate data structure for a particular problem or scenario is crucial for ensuring efficient operations and minimizing resource usage. That's why we need to study data structures elaborately. What is an algorithm? It is a step by step procedure or a set of rules used to solve a specific problem or perform a computation. We can say that it is a systematic approach to solving problems or performing computations. It is essentially a well defined step by step procedure or a set of rules that provides a clear sequence of actions to achieve a specific objective. They are expressed in a precise and unambiguous manner, often using pseudocode, flowcharts, or programming languages to provide a clear representation of the steps involved. Algorithms are crucial in computing because they enable us to design efficient solutions to complex problems and automate various tasks. The key characteristics of algorithms are well defined. It has to have one or more inputs and produce a corresponding output after executing the defined task. Finiteness. Algorithms must eventually terminate after a finite number of steps. There should be no infinite loops or never ending computations. Determinism. Algorithms are deterministic, meaning they produce the same output for a given set of inputs every time they are executed. Feasibility. Algorithms describe a feasible method of solving the problem, meaning that they can be practically implemented using available resources. Most importantly, it must be generic. Algorithms should be designed in a way that they can be applied to a broad range of instances of the same problem. What are the key properties of an array data structure? An array is a fundamental data structure in computer programming. It allows for storage of multiple elements of the same data type in a contiguous block of memory. It is usually characterized by three main properties: fixed size, containing elements of the same data type, and allow for random access to elements using their index. There are some exceptions recently. Many programming languages such as Python, JavaScript, Ruby, PHP, Perl, Swift allow different data types to be stored in an array. Similarly, programming languages such as Python, JavaScript, Ruby, PHP, Perl, Swift allow different data types to be stored in array. Each element in that array is assigned an index, starting from 0 for the first element and increasing sequentially for subsequent elements. This index allows for efficient and direct access to any elements in the array. This property is called random access because elements can be accessed in constant time. What is the time complexity of accessing an element in an array? So the time complexity of accessing an element in an array is order of 1 because it can be done in a single operation using the index. Explain the concept of a linked list. Linked list belongs to the category of linear data structure. In linear data structures, elements are organized in a linear or sequential manner, meaning that Each element has a unique predecessor and successor, of course, except for the first and last elements. Linked list consists of nodes where each node contains two parts, the data or value it holds and a reference to the or pointer to the next node in the sequence. So a linked list is a linear data structure where elements are stored in nodes. Each node contains data and a reference to the next node in the sequence. The key characteristics of a linked list is that the elements are not stored at contiguous memory location like arrays, but they are connected through pointers forming a chain-like structure. This allows for dynamic memory allocation, making it easy to insert and delete elements at any position in the list. There are different types of linked list, such as singly linked list, doubly linked list, and circular linked list, each with variations in their node structures and connectivity. Linked lists are commonly used in various applications and algorithms due to their flexibility and efficient memory utilization, especially when the size of the list changes frequently during program execution. What are the advantages of a linked list over an array? Linked list offers several advantages over arrays, making them suitable for specific use cases. Here are some of the advantages. Dynamic size. Linked lists have a dynamic size, meaning they can grow or shrink during runtime. Unlike arrays which have a fixed size, linked list can accommodate new elements without requiring pre-allocation of memory. Efficient insertion and deletion. Inserting or deleting elements in a linked list can be more efficient compared to arrays. In linked list, adding or removing elements involves changing a few pointers to adjust the connections between the nodes. While in arrays, these operations may require shifting elements, resulting in higher time complexity. Memory utilization. Linked list can be more memory efficient, especially when dealing with sparse data or elements of varying sizes. In an array, memory must be allocated for all elements even if they are not being used. In contrast, linked list only allocate memory for the elements actually present in the list. The fourth advantage is easy to reorganize. Linked list can be easily reorganized by rearranging the pointers, whereas arrays require extensive shifting of elements to change their order. No contiguous memory requirement. Linked lists do not require contiguous memory blocks, which can be a significant advantage when dealing with fragmented memory or when elements need to be scattered across different locations. No fixed size limit. Linked lists do not have a fixed size limit imposed by the initial memory allocation, making them more flexible for applications where the data size is not known in advance. Despite these advantages, linked lists also have some drawbacks. They require extra memory for storing pointers, and accessing elements in a linked list takes longer due to the indirect nature of accessing elements via pointers. Additionally, random access to elements like array indexing is not efficient in linked list compared to arrays. So choosing between a linked list and an array depends on the specific requirement of a problem. If dynamic size, efficient insertion, deletion, and memory flexibility are crucial, you can go for linked list. On the other hand, if constant time random access and memory efficiency is needed, then you can go for arrays. What is the time complexity for inserting an element into a linked list? The time complexity for inserting an element into a linked list depends on the position where the element is being inserted. There are three main cases to consider. One is inserting at the beginning, insertion at the end, insertion in the middle. Inserting an element at the beginning takes order of 1, while inserting in the middle of the list, it will take an average of order of n. But when you are inserting at the end of the linked list, it takes order of n. We have to traverse the entire list to reach the last node and then create a new node and update the next pointer of the last node to point to the new node. So it will be order of n. Hope this video is useful to you. Thank you for watching.